Carol Orzel likes to look her best, but for her, the routine job of putting on makeup requires some adaptation because her body's almost frozen by a shell of bone. She has fibrodysplasia ossificans progressiva. Basically, it means bones grow where they aren't supposed to, distorting the body and locking its joints. It's an extremely rare genetic disease which affects just a few dozen people.
I met Carol back in 1985 when her physician at the Inglis House asked me to see her because she was having problems with extra bone formation. And I had never seen FOP. I'd heard about it in medical school, but I'd never seen a patient with FOP before. And I saw this woman who was in prison in a second skeleton of bone.
Carol Orzel was one of the first people with FOP that I met. She was a wonderful person and an inspiration.
She's always been portrayed as this very funny, smart, witty person, someone who cared a lot about her looks, and someone who always had something to say.
She was young and energetic and full of life.
Carol really enjoyed making tools, and she would use them to apply her makeup. She had very little movement left. She had some movement of her wrists and some movement of her fingers, and she was able to manipulate these devices, these sticks, to apply her makeup. She always wanted to look her very best. Back in 1988, I was at Children's Hospital one day, and I was speaking to their fellows, and Dr. Zasloff approached me and said, "Do you know about FOP?" And I said, "Oh, fibrodysplasia ossificans progressiva." Dr. Zasloff was the chief of genetics at Children's Hospital in Philadelphia, and he had just arrived from the National Institutes of Health. And he said, "You know about it?" And I said, "Well, I have two patients, and one of them happened to be Carol." He says, "Well, we should work on this. This is a very compelling problem, and I'll teach you molecular biology if you teach me bones." And I said, "Okay." And that's how we started working on it. About a year later, or 2 years later, we recruited Eileen M, and we established a laboratory and a center for the care of FOP patients. And we went from seeing 2 patients to almost 1,000 patients now with FOP.
So FOP, which is fibrodysplasia ossificans progressiva, is an ultra-rare genetic disease that turns the skeletal muscle and the connective tissue into bone.
Our bodies have many cells and many tissues with specialized function, but we don't start out our lives as a combination of all these different kinds of cells. We start as a single cell that divides, and there are 2 cells, and then there are 4 cells. As those cells begin to divide, and as we begin to develop and grow during the earliest stages of our lives, those cells begin to take on more specialized identities. And this happens gradually over time. And when we're born, we have pretty much a full complement of all the types of cells and tissues. And one of the other really special things about our bodies is that we retain an ability so that if we have damage to our tissues, that those tissues can repair themselves. But in FOP, something different happens, and bone starts to form in other tissues like skeletal muscle.
Children with FOP look normal at birth, except for most of them have what look like bunions, but they're really malformations of the great toe. Otherwise, they move fine. They often scoot around on their butt because there are fusions, not just the joints of the toe, but other joints of the body, the neck, where the ribs join the spine, don't form properly, and they can't expand their chest as well. But that's not so obvious at birth. At 2 to 5 years of age, usually, painful swellings that look like tumors begin to seize the skeletal muscles, tendons, ligaments, soft tissues of the body, and turn them into bone. Eventually, ribbons and sheets and plates of bone replace the body's skeletal muscles and soft tissues, span the joints, and render movement impossible. And any attempt to remove this extra bone leads to catastrophic explosions of new bone growth. So trauma, injury, inflammation can cause new bone growth.
So in the United States, a disease is defined as being rare if it affects less than 200,000 people. And so with FOP, we know of about 300 patients living with FOP in the United States and about 900 worldwide. We estimate that there should be about 3,000 to 5,000 people living with FOP worldwide, but a lot of them remain undiagnosed.
There's a current effort to locate patients who are around the world and connect them. Jeannie Pieper started the IFOPA, the International FOP Association, back in 1988. She was a patient of Dr. Zaslav's at the National Institute of Health. And she said, I want to end the isolation of FOP. And she formed the International FOP Association. There were maybe 5 or 10, 12 patients with FOP. Now the FOP has grown. It's an international organization. There are patients all over the world. Most patients who have FOP live with their families, live at home. Some live very independently. They have helpers and aides. Most patients by the age of 30 require help with their activities of daily living, including bathing and toileting and eating and dressing and moving about. But FOP does not affect the mind, does not affect the human spirit. And we have many patients who have FOP who live very full lives. You know, we have doctors, physicians who are FOP patients. We have FOP patients who are attorneys or business people or teachers or housewives, or moms and dads. So living with FOP is a very difficult situation, but patients have the willpower and the determination to not only endure, but to prevail.
It was absolutely terrific to have Carol at the lab when, it was the official lab opening and the real start of research in FOP.
When we opened the lab in 1992, we dedicated ourselves and the community to finding answers. That was the first day that we really declared war on FOP.
I think we were all convinced that FOP was a genetic disease, and it wasn't a matter of if we could find the gene. It was just a matter of time and technology for us to come up with the answer. And there wasn't anybody who was a bigger cheerleader than Carol.
At the time we established the FOP laboratory, from the moment that Carol cut that ribbon, we were the only laboratory in the world that was really dedicated to working on FOP. Now there are over 30 laboratories and centers in the world.
One of the things I remember about that day is Carol looked terrific. I mean, I never saw Carol where she wasn't impeccably dressed, perfect makeup.
She would come in every year and greet the Penn medical students and teach them about FOP so that every student that graduated from the University of Pennsylvania Medical School knew about FOP if they ever encountered it in the future. They knew Carol like a friend, not just a patient. And she would often use some colorful language in describing FOP, much more colorful than I can use today. They asked her, what was it like to live with FOP? And Carol didn't mince words. She actually told them, and she would laugh and smile. And the students absolutely loved her.
I do remember her visiting us every year in the lab on her birthday. Her birthday was the day that we formally opened our research laboratory. I think she was convinced that, the FOP lab was a big birthday present for her.
Carol was a pioneer in education, pioneer in research, pioneer in teaching all of us about FOP. And Carol contributed her blood to finding the FOP gene.
If we asked the question for the first time today, we could probably have an answer in about 2 weeks. But at that time, the technology wasn't there to just say, okay, we'll just look at everything. We start out life as a single cell that divides and divides and divides. And during the process of the cells dividing and multiplying, all of the DNA in each cell needs to be duplicated and copied every time a cell divides. As amazing as our cells are and copying that DNA very, very precisely, every once in a while, a mistake slips by. And this is what we call just a spontaneous mutation. This happens randomly. It happens all the time, and everybody, and most of the time has no effect But it depended on us identifying families where FOP was inherited from parents to child. And although most cases of FOP are de novo new mutations in the person who has FOP, there have been a handful of families, about 10, where we have seen transmission of the FOP from a parent who has the condition to a child who then has the condition. And we were able to use the DNA from those families and basically map out where there were changes in the DNA and what correlated with the disease. I remember Meiqi Xu, who is the first person that I hired at Penn. We had done our family study. We had some good candidates, ideas from that study, what the FOP gene might be. And one of the things that Meiqi did was do the DNA sequence analysis. So she comes into my office and she says, I think I found the gene. Now she has come into my office a dozen times and said, I think I find the gene. And then, I say, okay, check this, just this. And nothing had panned out before. But this day was a little bit different. She, said, I think I found the gene. And she showed me your data and I looked at it. And I think immediately I knew that was it.
About 97% of patients with FOP have the same identical misspelled letter. And that one letter causes a change in the protein that signals the cell not to stay as a muscle cell or a tendon cell or a soft connective tissue cell, but to turn into bone. It's like a faucet that drips, and that drippiness probably causes increased signaling of certain molecules and cause the abnormality in the toe that's seen at birth, causes certain joints not to form properly. And then after birth, it's sort of like a broken faucet. You turn it on and it explodes with water all over the place. The water is sort of like a metaphor for the signal that tells this cell to make bone.
And we were really surprised because every single person had exactly the same DNA mutation, which is really unusual among genetic diseases.
We identified the gene. We knew what the cause of the problem was, and that opened up an entire realm of possibilities for treatment. And right now we have clinical trials that are based on the discovery of the FOP gene. We can target different aspects of that pathway and potentially the broken faucet itself and block it and hopefully someday even correct it, maybe even do gene therapy and replace broken faucets in the cells that make a difference, the muscle cells, the tendon cells, the ligament cells, the soft connective tissue cells. There were no interest by the pharmaceutical companies in FOP until we found the gene, and after that, it was explosive. Carol got FOP because it was a spontaneous mutation when she was an embryo. And that's how most people get FOP. When someone has FOP, they could pass it on. Now, Carol didn't marry or have children, but we have had patients who have FOP who have married and have kids. And that one genetic change, that one genetic letter out of 6 billion caused her incredible hardship and problems throughout life.
One of the reasons that we think it's unlikely that Carol would have inherited the FOP mutation from her parents is because her parents are not reported to have FOP. We don't see any cases, or we have no known cases of somebody who has an FOP mutation and doesn't show signs of the condition.
We had symposiums back in 1991, 1995, and 2000, where we brought together doctors and scientists and patients to teach about FOP. And we wanted the doctors and scientists to meet the patients so they knew about FOP. They couldn't see inside the body. So we asked them at our museum if we could borrow the skeleton of Harry Eastlack to take over to the symposium in Philadelphia. I was with Carol when she saw Harry's skeleton. And she turned to me and laughed and said, when my time comes, I want to be with Harry. But there's one stipulation. you have to put my jewelry on my skeleton. Well, her wish was fulfilled. Her skeleton eventually came to the Mutter Museum, but the jewelry was not on her skeleton, it was with her skeleton.
Carol's skeleton has been remarkable to see the effect of FOP on the skeleton, which is a very rare disease, but then see that coexist with a very common disease, which is osteoporosis. So osteoporosis can affect about 50% of postmenopausal women. It's a disease where you have weakened bones that are at increased risk of breaking or having fractures. And because of Carol's FOP, she was wheelchair bound. And so immobilization can contribute to osteoporosis. Also, the medications that she was on have very negative effects on her bone. And to really see the severity of her osteoporosis that has gone undiagnosed or unrecognized for so many years was very remarkable.
FOP not only affects the bone, it's not only bone formation, but joints as well. So if you go to see Carol's skeleton, look at the joints very carefully, look at the neck bones where they're joined, look in the back. FOP is not only a clue to bone formation, but it's also a clue to have the joints form and degenerate early.
When I meet someone who has FOP, I'm seeing them from the outside. And when I see Carol and Harry at the Mutter, I'm seeing the inside of the body and what FOP does to the inside of the body. And it's just so striking how the bone forms, where the bone forms. We've had dozens and dozens of students who have gone to the Mutter and seen Harry and now Carol. And I think that really makes a big impression.
In her second life in the Mutter Museum, Carol continues to teach. And I often say that Carol and Harry bypassed the grave for an institution of higher learning.
The more we learn about FOP, the more we realize what we don't know and what are important questions to ask. What's the process that allows these misdirected cells that are forming bone, what allows them to do that? And what gives them the signals, the information to actually permit that to happen?
What we do know is that do no harm is an actual effective therapy. Muscle trauma, falls, surgeries can really exacerbate the disease and can worsen the progression of the disease. And so educating the patients and the families about certain procedures that they can do. So for example, subcutaneous injections or putting an IV, as long as it's done by an experienced team, is safe in FOP patients, but trying to avoid intramuscular injections and surgeries.
FOP is relevant to every condition that affects the skeleton and every condition that affects bone formation in human beings. I remember a time when Harry was in a corner. It was in a cabinet. And I often thought that the key to the closet, the key to this cabinet, is the key to the kingdom. The key to FOP is the key to almost every skeletal disease. One genetic letter out of 6 billion is the key that causes this entire second skeleton to form. There's a whole cadre of doctors and researchers that are interested in FOP, not to cure extra bone formation, but to use that to make extra bone for those who desperately need extra bone. Children who are born with limb deformities, who are born without extra bone. We could help millions of people. She was frozen in the second skeleton of bone, but she enjoyed life and lived every moment to the fullest. You know, life throws all of us curveballs, and we deal with them, not with disgust and horror and anger, but with equanimity and valor and a sense of life. And Carol taught me that.
Happy birthday, Carol. Thank you for everything that you've given all of us at the research lab, studying FOP, everything that you've given me. You'll live in our hearts forever, and you'll never grow old. We love you.
Happy birthday, Carol. I really hope we're making you proud, and thank you for all your contributions to the FOP community.
Carol is immortal. Carol's memory and life continues on in a second life of education, of stimulating research, of stimulating doctors and scientists around the world to learn about FOP, and her memory and her soul will live on forever. Carol, happy birthday, and thank you.